description of an algorithm. Now we need to get to the coding part. Yeah. 8.1, we focus on the problem solving part. Yeah. Because we need to find a solution first. Given a computing problem, we need to find a solution first. For 8.2, after we have a solution, we need to implement. We need to write a program to implement our algorithm. So we look at that topic, description of an algorithm. Okay, all right, yeah. So first, the goal, find a solution for a computing problem. Yeah, so that's the general goal for, this course. Yeah. After the training of this algorithm course, then when we go to the real world, we need to find a solution for a computing problem. Here, I use this general expression, computing problem, to represent, the general, real world problems. It could be, for example, it could be a sorting problem. You may ask me, what is a computing problem? Okay, what is a computing problem? Yeah. For example, sorting, sorting, giving an array. You need to sort this array in ascending order. That's a computing problem. Okay, that's a computing problem. General computing problem. Okay, yeah. All right, so then to find a solution, we need a precisely defined procedure to get the answer, step by step. Yeah. You need to know all the details to find your solution. Okay, first you have a general idea, so then you need to fix all the details before you can write a program. Okay, yeah. All right, step-by-step implementation details. Yeah, all right. And usually, sometimes when we work on a relatively complicated project, okay, yeah, we need to use flowchart to organize our thinking. Yeah. Otherwise, we may get lost, right? Too many steps, very complicated, so many different things we need to cover, yeah. In that situation, we may need to do the flowchart, try to organize our thinking clearly, so we can, when we do the implementation, so we can implement it block by block, step by step. Yeah, so just like the diagram you see here. Yeah, all right. Then each step can be represented in code. Yeah, for the implementation, you need to implement each step in code. Yeah. All right. So then you will get a computer program. Okay. So then you use the tools, appropriate tools, to generate your computer program. Okay. So right now, typically we use IDE. Okay. IDE. So that's integrated environment. Integrated development environment, IDE. Yeah, people call IDE. Okay, IDE, integrated development environment, IDE. Yeah. Here, the reason I mention this, because I noticed many students, they do not use IDE. They use the online compilers. Yeah, because when we write our programs, I noticed from my previous students, many students, they use online compilers. That's fine with me. That's fine with me. Online compilers. Yeah. But if it's possible, I recommend you use IDE to write your code. The reason is simple. When you use IDE, you can develop more complex projects. For online compilers, because usually you need to put everything in one file, right? If you have multiple files, it may not be convenient for online compilers. Yeah. So a better way is the IDE way. Yeah. But for this class, I do not force you to use IDE. So online compiler is still an option for you, because for many students, so they feel hard to use IDEs. But if it's possible, try your best to use IDEs. Okay. But if you use online compilers, still fine. I will not take any point off. And all my projects, all my two programming projects, you can use a single file way to complete it. So no problem. So you can complete the two projects using online compilers. All right. So now, summary, what is an algorithm? Based on our implement. So here we use the implementation point of view to look at the algorithm. A sequence of instructions. Okay, so we need to generate a sequence of instructions to cover all the details of an algorithm. And each instruction should be unambiguous. Should be clear. The meanings of everything should be very clear. Unambiguous. And input data. So input data must be given, and the data must be legitimate. So usually that means we need to do data validation. So there is a data validation step to make sure the input data is legitimate. Then the output. So the output, you need to follow the requirements. So usually for a typical computing problem, usually think about in the business world, you need to solve some particular computing problem for your customers. Okay? You need to find computing solutions for your customers. Okay? So your customers will provide you the requirements for the output. Requirements. You need to follow those requirements. Okay? For the output. So it must be in the required format. All right. Then another important factor in order to deliver a good solution for your customers, you need to really consider this execution time. Execution time is very important. How fast is your algorithm? That's extremely important for your customers. If it's too slow, your customers may not accept the solution, reject your solution because it's too slow. Okay, useless. It could be possible. So then you can see from this factor, you can see response time or performance or efficiency. Later sometimes we use performance, sometimes we use efficiency of the algorithm. Very important. So for this class, we will spend a lot of time to improve the efficiency. Yeah. Every time when we have an algorithm, we need to ask ourselves, can we improve it further? Can we improve it further, right? Is it the best solution we can find, right? Yeah. So that's all about efficiency, execution time. Okay? Yeah. All right. In our part B, because today we will run out of time quickly today, so we cannot do part B. So I like to start the whole part B topic in our next meeting, next lecture, yeah, because it's a very big, important topic. Yeah. In part B, we will right, good, yeah, I will make comments later, yeah. So in part B, we will really do the comparison on two different algorithms on the same computing problem. One is very bad and one is very good. And you will see how big is the difference. So I like you to feel about it. How big is the difference? Two different solutions. One very slow, one very fast. Okay? And after that, we will do our first programming project. Part B, the part B topic, we will do our first programming project. Okay? All right, so now let me make comments on Dakota's question. Then are we gonna look at, oh yeah, that's the asymptotic notation. Big O of n, big O of n squared, right? We call this kind of special notation called asymptotic notations. Yeah, that's a big part of this class, asymptotic notation. That's our module 2 topic. In our module 2, we will study this abstract concept. This concept, very abstract, but it's important. Yeah, so because we will use this language after module 2, we will use this asymptotic notations a lot. Okay. All right. Yeah. So let me continue. Finish the current topic first. All right. Then the execution time should be finite amount. That's the minimum requirement, right? Because it's impossible to have infinite amount with execution time. That means there is no termination of your program. You have some infinite loop, no termination. The minimum requirement is your program must terminate at some point. Okay? But you should not be satisfied with the finite amount. Yeah, because finite amount, it could be a very large number. Yeah, the response time could be a very large number. So we need to make sure we can make our algorithm the fastest. We will make the effort to get the fastest possible algorithm. Okay? Yeah. Yeah. Because the faster the algorithms, the minimum the computing cost. Now, computing time actually could be very expensive. Computing time. Yeah. So we want to make our algorithm the fastest possible. That's critical in the real world applications. Response time, it's critical. Okay. Yeah. So that's why that's our highest priority, to reduce the execution time as much as we can. Okay. Yeah. All right. Yeah. And you also because you need to make your customers happy, right? So when you deliver a solution, the response time should be acceptable to your users, to your customers. Otherwise, you cannot get the money, right? Your customers may not pay for your solution, yeah, because your solution is too bad. Okay, yeah. So that's a very big deal here. All right, yeah. All right. So we finish our A